is the last number and is also the y-intercept. And that's good to know, is that the last number, and actually the last number in any equation, as long as it's in standard form, is always the y-intercept. Okay, and then cubic, same thing, except for now it's A, B, C, D, and D is the y-intercept. Okay, so the last number is always the y-intercept if it's in standard form. So this is the y-intercept there. Okay, so all the time that last number, if you're asked for the y-intercept, you can always type it into the calculator and do what we did yesterday, like press trace 0, enter, it'll give it to you. But just knowing that you can look at an equation and the last number is the y-intercept is useful too. Okay, those. Now we're going to get into this. So this is the typical type of question. You'll definitely be asked this on the test. To do this with the graph, and we were doing it yesterday as well, so it's really not new. It's pretty much exactly what we saw yesterday. We'll do it here with a couple different examples. So if you're given 3x minus 5, what type of graph is that? Linear. That's linear. I can tell right away because there's just an exponent of 1, or no exponent at all, but there is an x. So it's linear. So I know that the possible number of x-intercepts is... Now, when it says possible number, the tricky thing here is it's not, it's actually, I really hate these questions, but they do ask them. The number of x-intercepts is always equal to, the possible number of x-intercepts is always equal to the degree. So here the degree would be, does anyone remember what the degree of this would be? 1, because the exponent is 1. So the number of possible x-intercepts is also 1. So it's just 1. Okay, so number of possible x-intercepts is 1. Okay, the y-intercept, if I look at this equation, you could type it in and look at it on the calculator screen, but I can tell looking at this that the y-intercept would be what? -5, that's right. So it's -5. The number of possible turning points, okay, that again, it's number of possible turning points. That's always one fewer than the degree. So 1 less than the degree. So the degree here is 1. So the number of possible turning points is 0. And that makes sense anyway because it's a line, right? A line can have a turning point. So makes sense. Okay, the domain for all linear functions is the same. What's the domain for all linear functions? Yeah. Thank you for checking though. Okay, so the domain for all linear functions, does anyone remember? XER, like that, with the curly brackets around it. Or you can write from -infinity to infinity. And that's for all linear functions. It's like that. The range, and actually, domain, that's just all functions are like that. Okay? All the functions we're going to see in this unit are like that. The range is the same here, but you would write YER or -infinity to infinity. That's scary. Okay, and end behavior. So end behavior here is the one you'd actually probably type it into your calculator to take a look at. So the graph here, if I graphed it, would look like this. So remember that we learned yesterday, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. And your end behavior is just saying what quadrant does it start in on the left and go to on the right. So first of all, on the left, it's always going to be in either quadrant 2 or 3. Okay? It can't start in quadrant 1. That doesn't make sense. It has to start in quadrant 2 or 3, and it's moving towards quadrant 1 or 4. So here, where does it start? 3, and it goes to 1. So it goes from quadrant 3 to quadrant 1. And that's all you have to write is something like that. Okay, just really short, short and simple, nothing too fancy. Okay, so this is really easy, I think. You need to actually do it, though. It's always shocking. I get students on the test who have no idea what half this stuff means. It's just practice. So I'm going to give you guys some practice today of it, and hopefully everyone can do it fine. Let's just look at a quadratic, because quadratics are a little harder. Okay, so the number of possible x-intercepts. that is not the number of actual x-intercepts. I know it's really weird, but when it says possible x-intercepts, all you're thinking about is it's a quadratic, so it could possibly have 2. Okay, that's the maximum number. Or actually, you could even write something like, if it's possible x-intercepts, you could even say, like, it could have, the options are, there could be 0 x-intercepts, there could be 1 x-intercept, or there could be 2 x-intercepts. Okay, those are all possibilities, depending on what the graph looks like. So if the graph is completely above the x-axis, and it doesn't even touch the x-axis, that's 0. If the graph, it just touches it, like, just barely touches it like this, then it has 1, and if it is like a normal or the usual one we see, it has 2. Okay, so that's how you can do that. Now, y-intercept, or honestly, if you just write 2, it's fine too. Either way, but don't put how many there actually are. So if you like type it into your calculator and see there's only 2, or there's 1, don't write 1. If it says possible, if it has the word possible in it, always look for that. What's the y-intercept of this equation? 8, and I know that just looking at it because it's the last number there. Okay, number of possible turning points. Okay, a quadratic, how many possible turning points does it have? 1. It just has 1 at either the top or the bottom. Okay, now the domain and range, not domain really, but range is the hard part. Domain's always the same. I hate it when I see students don't know how to do it. It's domain is just XER, okay, or negative infinity to infinity. And again, you do not have to write both of those. You just write whichever one you prefer. Okay, just whichever you prefer. And then range here is the tough part. So range, you have to graph the function. So let's do this on our calculator right now. Everybody try it because I'm sure people have forgotten how to do this. So if you open up your calculator and you graph this, you can do whatever way you want, either time, I guess. I don't care. Okay? Like, you mean, like, can you do interval for one and set for the other? That's what you're asking, right? Yeah, that's fine. Okay, so if you graph this, okay, you get a picture. Guys, shh. I suggest doing this because I'm going to remind you about some buttons and how to press them properly, so I suggest actually trying it. Otherwise, in a few minutes, when you actually have to do this, you're all going to be asking me how to do it. Oh, that's not very good. Okay, so it looks something like this on my screen. Okay, it's just an upside down function. We call it decreasing. This is a decreasing quadratic equation. It's because it's like sad looking. The top there is what tells us the range. So this point here, this is what we call the maximum in this case, because it's the top of the graph. And we need to be able to figure out that value using our calculator. So does anyone remember what you press in order to do that? No, that gives you the y-intercept. Yeah. Yeah, how do you do that though? You hit second trace. So hit second trace and a list of stuff comes up. So when you hit second trace, a list of things come up. It says 1 is value, 2 is 0, 3 is minimum, 4 is maximum. If you want the maximum, you hit the 4th option. So you hit second trace 4. So you go second trace. You go 4 for max. And then you have to go to the left of the maximum. So you have to actually scroll over to the left of the maximum. And you press enter. Then it says right bound. And you have to go to the right of the maximum and press enter. And then you have to press enter one more time. So it's quite a number of steps. Okay, so I go over to the right. I press enter one more time, and what do you get? Does anyone get a value? -1 and 10. So I get the point is -1, 10. Okay, that's the value. So the top, the maximum, just like somebody said, is 10. because that's the highest value. That's where it's up on the y-axis. So that 10 is what's important here. So you write that as either you write y is less than or equal to 10 because it starts at 10 and goes downwards, y-er, or you write from negative infinity to positive 10. Okay, and remember for that, and actually, sorry, positive 10 should have square bracket. So remember for that, it has to be that you start at the lowest value, which is negative infinity, up to the highest, which is 10. If you have a graph that goes the other way, so if you have a graph that opens upwards, it's different. You would say it starts at, say this was 2, you would say it starts at 2 and goes to infinity. Okay, so it's always the lower number first. So you shouldn't have like 2 to negative infinity. That doesn't make sense. Or you shouldn't have infinity to negative 3 or something like that. That doesn't make sense either. I never see that, though. It's the other way that people get confused with. Okay, so domain and range, and then end behavior. Pretty simple. End behavior here. What quadrant does it start in? 3, and it goes to 4. Okay, so it starts down in 3, ends down in 4. Okay, and that's how you do it. Okay, so you need to know those button presses. Like, you need to be able to do that. You learned it in grade 11, and you had to do it quite a few times in grade 11, so hopefully it's at least familiar, unless in grade 11 you, like, really avoided doing that unit or something. So, hopefully everyone can press the buttons. If you need a little help when we're practicing, let me know, and I'll walk you through it. Okay, and now cubic I'm actually going to skip, but it's exactly the same, except domain and range are the same as linear. Okay, so domain and, write that down here, just because I want to get to the practice here. Domain and range yeah, I'm teaching right now. What's up? Yeah, I am teaching. Come back and see me in 15 minutes. Okay, so domain and range is the same as linear because it's going up and down forever, it's going right and left forever, so it's just both XER, YER, or negative infinity to positive infinity. Okay, everything else is pretty much the same too, so it's pretty. Okay, now this is the only other question I want to do here. Okay, so it says sketch a graph of the possible polynomial function for each set of characteristics below. A, what can you conclude about the function, the equation of the function with these characteristics, blah, blah, blah. Okay, so A, if I wanted to draw a function that met this requirement, where it says y such that y is greater than or equal to negative 2, YER. What type of function do I automatically know that has to be? Quadratic. It has to be quadratic because it has a restriction in the domain. That's what we, or in the range rather. That's what we say, it has a restriction. We're saying it has to be higher than negative 2. A linear function can't be like that because a linear function goes up and down forever, so it can't stop at negative 2. You're not allowed to do that. The only type of function that stops somewhere is quadratic. So I know that my function, if I mark negative 2 on my graph, I know that my function has to be, it says, greater than that. So should my quadratic function be opening upwards or downwards? Should it be like a smile or a frown? If it's greater than? Smile. A smile, okay? I heard a few people say it. People aren't sure. It is smile. So it's greater than. It has to be higher than 2. So it's going to start at negative 2 and go upwards. And it has to have a y-intercept of 4. So it has to go through 4 on the y-axis. And you could draw it a number of different ways. I could draw it on the left or on the right. It doesn't really matter because it doesn't say. So I'll just draw it over there. Woo! It's pretty crazy there. And it doesn't ask for you to come up with an equation. It just says, what do you know about the equation? So what I would know about the equation here, and there are a couple things I know, and that I might notice. Does anyone know the number that we call up front? So when we have a quadratic in standard position, in standard form, so ax squared plus bx plus c, the fact that this quadratic is like a smile, it's opening upwards, that tells me something about a. What does it tell me about a? Does anyone know? It's positive, that's right. And you learned that in 20-1 and 2. So because it's a smile, it's opening upwards, we call it increasing. It is positive. I don't really know anything about b in this case, But I know that c has to be equal to what? 4. Because c, that last number, is the y-intercept. So I know c is equal to 4. And that's all you can really say about the equation. Okay, now the second one, it says the range is YER. And there's turning points. There's one in quadrant 3 and another in quadrant 1. So if a graph has 2 turning points, what type of graph is it? Cubic. It has to be cubic. Linear has none, and quadratic has 1. So if it has 2, it has to be cubic. And so again, you can draw any kind of thing you want really here, except we know it has to turn once in quadrant 3 and once in quadrant 1. And there's more than one way to do that, just so you know, like this is 3 and this is 1. Sorry. This is 3 and this is 1. I could draw it like this. That would work. Okay, or I could draw it. Oh no, I guess that doesn't work. Here, let me try again. Oh, I guess maybe I can't do it that way. Yeah, I guess that's kind of the only way you can draw it, because you can't draw it going up. If I try drawing it going up, I have to make it turn here, and then it can't turn again in 1. So that, I guess, is the only way I can draw it. Okay, something like that. So here, does anyone know, would I say that this cubic function is increasing, or would I say it's decreasing? Is this increasing or decreasing? And I hear people saying it, it's decreasing. This is decreasing. And like I said, people have trouble telling sometimes. But the way you tell is you start on the left, and you just see what your pen does. So it goes down, it goes up for a bit, but it goes down again. In the end, it's going down. That means it's decreasing. This is a decreasing function, which again means that our a has to be negative. Okay, that's what makes an equation decreasing, is if that a value is negative. Okay, so if a is negative, it's decreasing.